Hi everyone, this is Miss Bennett. I am going to take you through thermodynamics, kinetics, and equilibrium, and this is meant to go along with your booklet, and we're going to start on page 1 of the notes, and we're going to start with thermodynamics. Remember and keep in mind that thermo equals heat. So we're going to be talking about a lot of heat energy during all of this video, but we're going to start with your thermodynamics. We're going to start with a couple of definitions. Phase and equilibrium. So phases of matter is where the matter is uniform, and the three states of matter that we know most about are the solid, liquid, and gas, and there is a fourth one, plasma. We just do not cover a lot of that in Chem 1. Also, another vocabulary word that you need to know is equilibrium, and that's the state where the forward and reverse reaction occurs at the same rate. And up until now, we've had reactants on one side going to the products of the reaction on the right-hand side. Now what we're going to be talking about is that how the forward reaction going from the reactants to the products equals the same rate, or occurs or can occur at the same rate as the products going to the reactants. So this reaction actually goes back and forth until equilibrium is reached. So let's start with some information that you've probably learned in your other science classes. The phase changes going between solid, liquid, and gas. To go from a solid to a liquid, that's melting. Gas to a liquid is condensation. Solid to a gas is sublimation. Liquid to a solid is freezing. Gas to a solid is deposition, and liquid to a gas is evaporation. In order for these changes to take place, heat energy either has to be added or taken away or given off during these processes. So let's go through and see which ones are adding and which one is giving off. To go from a solid to a liquid, heat energy has to be taken in. You have to add some heat in order to go from a solid to a liquid, just if you were to leave a chocolate candy bar in your car on a hot day. To go from a gas to a liquid, you have to take away heat. That is condensation. To go from a solid directly to a gas, you're adding heat. Liquid to a solid, you're taking away heat. Heat has to be given off. Gas to a solid, taking away heat once again. And liquid to a gas, evaporation. We have to add heat. So if we put that in terms of solid to a liquid to a gas, in order to go from solid liquid to a gas, we are adding thermal energy or adding heat. To go from gas to a liquid to a solid, heat is given off. So we're going to be talking a lot about heat in these lectures. Another vocabulary word you need to know is vapor pressure. Vapor pressure is the partial pressure exerted by a vapor that is in equilibrium with its liquid state. Vapor is just another fancy word for gas. So vapor pressure is the pressure exerted by those molecules trying to escape that liquid phase. And when you have the vapor pressure equal to the atmospheric pressure, or the pressure in the air around the liquid, this is where you're going to have the boiling point. And as temperature increases, vapor pressure will increase as well. There are two types of graphs that we're going to take a look at with heat. One is the phase diagram, and the other is a heat curve. We're going to start with the phase diagram. The phase diagram basically is the relationship between the physical states of a substance, and we're going to be looking at temperature and pressure in a phase diagram. And what we can do is we can use this phase diagram to predict what state our substance is going to be in depending on that temperature and pressure. So if we take a look at one, like this one, we've got temperature along the bottom, we've got pressure up the side, and this is pressure in PSIs, or pounds per square inch. A lot of times you'll also see pressure in atmospheres, ATM, and usually temperature is going to be in degrees Celsius. But if you look at this, as we increase temperature here and we're increasing pressure as well, we have the gas phase, the solid phase, and the liquid phase. So in this case, as we're coming up this line here, we see where that at the different temperatures and pressures that we can have, for instance, if we pick this point, we can see the pressure off to the side, and we can see the temperature that we will have a gas. Along these lines is where you will actually see equilibrium taking place, and here you've got sublimation and deposition, or desublime is another word for deposition, in equilibrium at that temperature and at that pressure. Between the solid and liquid, you have melting and freezing in equilibrium along that line where that temperature and pressure is. Also, between the gas and the liquid, you have condensation and evaporation in equilibrium along that part of the graph. So this just shows you the different temperatures and pressures that a certain substance will exist. There's a YouTube link up here that will be posted on the website as well, so you can refer to the Chem Squad website. So, a couple of different things about these phase diagrams to know is a triple point, the critical point, in the supercritical fluid or supercritical point. The triple point is the temperature and pressure that all three phases exist at the same time in equilibrium. There is a video online that will show you that. The critical point is where the temperature and pressure where the gas and liquid become identical. And the supercritical is when the liquid and vapor are, you can't tell the difference between the two. So let's take a look at a graph so you can see where these points lie. So if we're looking at water, you guys at this point know that water should freeze at 0 degrees Celsius and boil at 100 degrees Celsius. So at 100 degrees Celsius and 1 atm, which is just standard air pressure at sea level, you will see that we get this line where we've got from the gas to the liquid. At 0 degrees, you can also see that we will also get the solid to a liquid, so freezing and melting in equilibrium. The triple point is this point right here. So at 0.01 degrees Celsius and 0.006 atmospheres of pressure, you can get solid, liquid, and gas, so ice, water, and vapor pressure, vapor, all existing at exactly the same time. So you'll see something boil, melt, and evaporate all at the same time. When you get to the critical point, which is up here, this is where it's if you look back at the definition, the temperature and pressure where the gas become identical and form one phase. So the liquid, which is right here, the blue area, and the gray area, the gas phase, all become indistinguishable where you can't tell the difference. They're in the same phase. But notice, very high temperature and very high pressure for that to take place. The supercritical point would be way beyond that, where you can't even tell the difference. This video of the triple point is of hexane, and you'll be able to see it boil, melt, and freeze all at the same time. You can look at the website. A second type of graph is the heat curve, and what this shows us is the point at which a substance melts and evaporates. And one thing to remember with the reason why a substance will go from one phase to the other is heat 'em up, speed 'em up. You'll hear this quite a bit. If you add heat, it's going to speed up the molecules. The molecules move faster and move further apart as well. When they move further apart, they overcome those intermolecular forces that we talked about in one of our earlier units, like hydrogen bonding, dipole-dipole, induced dipole-dipole, those intermolecular forces. Therefore, we're going to get a phase change. So it going from a solid to a liquid back to a solid. Okay. So here's an example of a heat curve. And this is of water. At 0 degrees, you guys know that at 0 degrees is where water will freeze. So down here is where I'm going to have a solid. At this point where it levels off is where I have an equilibrium point, where as it's going from solid to a liquid, melting is in equilibrium with freezing. Once we get above 0 degrees, we have our liquid. When it levels off again at 100 degrees, when a liquid becomes a gas, where we've got evaporation, is in equilibrium with condensation at that point on the graph. Above 100 degrees or at 100 degrees and above is where we're going to get our gas. And that's kind of misleading because really water, once it hits that 100 degrees and begins to boil, it will stay at the 100 degrees. Now, notice one thing here. We've got increasing energy here. So we're increasing temperature. If you're increasing temperature, it's heat 'em up, speed 'em up. We're going to speed up those molecules. We're going to give them more kinetic energy. And that kinetic energy causes those molecules to move around more and more and more and spread out more and more and more, so we can go from a solid to a liquid to a gas. So temperature is proportional to the amount of kinetic energy the molecules have. All right, let's talk about heat and energy transfer in just a little more depth. All right, the question is, if I have a cup of hot water and a cup of cold water, which will dissolve a spoon of sugar faster? What do you think? Should be hot water. That's why if you're ever making Jell-O, you put the Jell-O in 1 cup of hot water first so that you can get it to dissolve, and then you add the 2nd cup of cold water so that you make the flavor what it should be. But the hot water will dissolve more because remember, heat 'em up, speed 'em up. So it's going to speed up those molecules so that they will dissolve and overcome intermolecular forces to go into solution. All right, some vocabulary words you need to get down. This is now on page 2. Energy is the ability to do work, the ability or capacity to do work, to make something move, to make something change. Heat is the energy transferred between objects that are at different temperatures. And one good thing to remember is it always goes from high temperature to low temperature. Joules are the units for any kind of energy, and in this case, heat energy or thermal energy. And the temperature is a measure of how hot or cold something it is. The average